How's everybody doing out there? AP Calculus! Isn't it a lovely day? Get it? Lovely day to do calculus. It is the day of love, the day of calculus. You can ask your parents and your teachers. Circa 1970, 7 o'clock, Channel 8. You know what they were watching? Channel 8 or ABC. Love American Style. Happy Valentine's Day, everybody, I'll tell you. How many days left do we have to AP? Before we answer, 89 to 89? I thought it was 82. I think it's 82. 89, we can't count. I can't count. I don't know, 89. Next week, it will be a full NBA season. See if any sports fans understand that analogy. We are going to do calculus today. I think a lot of you have a test tomorrow, so I'm going to try to help you prepare you for that test. Who's on the line? Is it Shamika Joe?
Hi.
My tie is a little crooked. Hey, Shamika. How you doing?
Fine.
Let's have a picture of Shamika Joe.
Oh.
Hey! Woo! How's it going?
Okay.
Okay. I got a little echo. Do you hear an echo from me?
Yeah.
Okay. So cool. Hey, you got a test tomorrow?
Huh?
Do you have a test tomorrow?
We already took it.
You already took it. Okay. Well, see if you can do this problem then.
Oh, okay.
Shamika Joe.
What? Take the derivative. It'd be
Hello?
EX squared times, E to the X squared times 2X.
Okay, well, I got you back. So I didn't hear we didn't hear anything you said. We had back.
Oh, you didn't? Okay, it's E to the X squared times 2X.
Okay. So what's f prime in natural log of 2? The square root of natural log of 2.
You plug that in.
Plug it in, plug it in.
It's over E, the square root, square root of natural log of 2 times, parentheses. You got the square root times 2 times square root of natural log of 2.
Can we simplify that at all?
Need to report first.
Could you tell Miss Kim? Could you tell Miss Kim not to do announcements during my show, please? Go down and tell her. Just kidding.
All the teachers that are being appraised
Wait,
by
let's listen.
Miss Kim
All the
need to
teachers
report
being
to the
appraised.
media center.
Being appraised by who?
I don't know.
Does Ms. Brzezinski have to report to the media center?
Yes, she does.
Uh-oh, trouble. Hey,
It's okay.
okay, what do we have to do here, Shamika? I mean, how can we simplify this part right here?
Oh, the square cancels.
So it's e to
The square root cancels.
Right, so it's e to the natural log of 2 times 2 natural square root of natural log
Sorry,
of 2.
correction. All
What's
teachers
e to the
that are
natural log of 2
being appraised by
equals?
Miss Kim, please report
It is
to 247.
What is it?
All teachers that are being appraised by
4.
Miss Kim, please.
E to the natural log of 2 is 4?
2.
It's 2. And 2 times 2 is 4, right?
4, yeah.
So the final answer is this, right?
Yeah.
Hey, let me ask you something.
Huh?
Can we simplify this puppy at all? Square root of natural log of 2, if we wanted to?
Yes.
What can we do?
Let's see.
Well, let me ask you something. Is the square root of natural log of true? It equals this, right?
Uh-huh.
Does that equal this, yes or no?
Put it up. Yep. Can you put it up?
Is it true that this is equal to that?
No.
No, it's not. It has to be this, right? These guys are equal.
Yeah.
But the parentheses kills it. So this is the final answer. That's good enough, right?
Uh-huh.
Shamika Joe!
Yay!
Make sure you call in again, all right?
Okay.
Okay, thanks. Jared, what's going on, dude?
Hey, Mr. Fly.
What's up?
I like your, pink shirt.
It's not pink.
Sure it is.
It's actually burgundy.
I'm wearing a pink shirt right now.
Hey, Well, you know, you're pretty secure in your masculinity. Where
Yeah, exactly.
you know, circa 1983. I bet Miss Arthur used to watch Love American Style in 1970.
I bet you did.
She was 2 years old at the time. Hey, my shirt is burgundy, but what? Do you have a test tomorrow?
Yes.
You do? Is it hard?
Yes. I'm not too familiar with that natural or the E to the X stuff yet.
Okay. Well, here, let's try this one then.
Okay.
The and we'll do problems until you are familiar with it.
Hello?
Yeah, I'm here.
Okay. I can't hear.
You don't have to hear. You just have to see.
Okay. All right. Let me think what I have to do.
When you integrate, what do you usually have to do? What do you have to figure out what to do?
U substitution?
Right. Now, here's the key. What are the possibilities of setting something equal to U? Give me a possibility. Hopefully no one's telling you the answer. What are the possibilities? I see like 3 or 4 things you could set equal to U. Name 1 or 2.
E to the X.
E to the X. What else could we set equal to U?
Or cosine of E to the X.
We could set it right. Okay. What else? Anything else? Well, you could set equal to X, to the exponent, right?
Uh-huh.
Which one do you want to try?
I want to try the first one.
Happy Valentine's Day. Oh, sorry.
Oh,
the first one.
Alicia.
How do you know her? No, that's Allison.
Oh.
Okay. No. So U is equal to E to the X. So du is equal to what?
E to the X times dx.
Right. So what is this in terms of U? How can we simplify that integral?
You can ex dx equals du.
Right. So that's du, and what is this equal to?
That equals
Cosine of what?
oh, cosine of
Female sheep. Female sheep.
what?
Female sheep.
U.
Yeah, it's cosine of U. Look,
Yeah.
this is cosine of U, right? Cosine of U,
Yeah,
and
that's
this
U.
is du. What's the integral of cosine U?
Sine.
I wanted a sine of U plus C. Oops. Sine of U plus C, right? So the answer is just sine of E to the X plus C, right? Wasn't that exciting?
Yes.
All right.
Can you work on this?
Yeah, okay, well, hey, I'm going to do them all show, so call them,
All right.
We'll hopefully get them done. Is this the great Noreen Napper?
I guess it is.
How you doing?
Good. How are you?
How's Gary doing?
Good.
Good.
Very good.
Tell him I say hi.
Okay, I will.
Hey, you could we have playback. Homer, where are the playbacks of this show?
You do?
Yeah, you could watch them together, and you could Saturdays at 9 or 10 or something like that, and Tuesdays nights, and
Okay.
we'll try to get the exact thing. Hey, you're really smart, right, Noreen?
Oh, I don't know.
Whoa. Okay. So I have to give you a hard problem.
Oh.
Do you have your test tomorrow?
Yes.
What's your test over?
It's over like natural logs and e to the x and stuff like that.
Natural logs and e to the x. Okay,
Yeah.
so let me give
and
you
anything Miss Harmon wants.
anything Miss Harmon wants, Miss Harmon gets, right?
Exactly.
Okay. How about Okay. How about this one here? Find the if f of x is equal to this, find all relative extrema. Noreen.
Okay. Well, first you have to use the first derivative, and so you have to take the first derivative.
All right. First derivative. What's first derivative?
And the first derivative is, let me see, let me work it out. Okay, so, oh, okay, so I'm going to use, like, the UV, the quotient
UV,
rule.
baby. UV, and commonly referred to as Hody High.
Right, yeah. Okay, so that's going to be x times e to the x minus e to the x times derivative of x, which is just 1,
Cool.
and then divide that by x squared.
There's no stopping Noreen Napper. Okay.
And then I guess we could clean it up a little bit.
I like
And
that.
you could
It's
say,
all dirty.
it is.
Needs a washcloth.
E to the x and then times just x minus 1.
Wow, that is really good. What she did was she factored out e to the x. Okay, good. So.
And then
Mr. Rodriguez, Jim Rodriguez.
Okay, now that's the
we
second
have an
time.
announcement.
No, tell Miss Barnhart.
Okay. I like my sign, thank you. Okay, so then both of them are positive because e to the x is always positive.
E to the x is always positive, and x squared is always positive.
Something squared is always positive. And
Tell us, what are you trying to figure out right now?
we're trying to figure out the relative extremas, so like
Right.
min and max.
So why did you tell me that they're both positive?
It was positive because I don't. I just said it.
I know, but in order to find out relative extrema, what are we looking for? I mean, why? You're on the right track.
Well, okay, you have to see what it changes from positive to negative.
Right. See what changes from positive to negative.
Oh, sorry. The derivative.
The derivatives. And so, how do you find out when a fraction changes from positive to negative?
So basically you would just look at the x minus 1 because e to the x is always positive and x squared.
You want to know where the numerator and denominator are equal to 0, right?
Right.
Okay, so we know the denominator is 0 at 0 and the numerator is 0 at 1. Since e to the x is always positive, it's never 0, right?
Exactly.
No, thank you. All right. So therefore, what do we do now?
So now you just have to, I guess plug in values.
Plug it in, plug it in. What do we want to plug in?
So now you can plug in like a number less than 1, so like 1/2.
Okay, and that's positive, negative, positive, so it's
Right,
a
so that
negative.
makes it negative.
Plug in 2, positive, positive, positive.
Right, so
Plug
we
in
have
negative 1, it's a positive, negative, positive, so it looks like that. So the
Right.
function decreases,
Decreases, and then
increases.
increases.
So
that means that we have a relative min at 1.
at 1 what?
Let's see. 1, and then your y value would be e. Yeah. Thank you.
Fine job, Maureen Napper.
you.
How's Lillian doing?
Thank you. What?
How's Lillian doing?
Oh, she's sitting right next to me, actually.
Is she?
Yeah, she's doing really well. Thank you.
You know, W.T. White has a habit of like putting people on who, because I know it was really you last time. I just didn't want to, cover.
Oh, is that what it was? You do.
Actually, Lil Birdie told me. Hey, are you going to the prep session a week from Saturday?
Yes, I think I am.
That's good because it's going to be a really good prep session.
Are you going to be there?
I am going to be there.
Really? Cool.
I'm going to be there, and I'm going to actually even attempt to teach in front of students.
Oh, wow.
So I'll do my best. Well, listen, call in again, all right?
I will.
It's nice
Thank
talking
you.
with you.
Thank you, and see you Saturday then.
All right.
Okay, bye.
Hello?
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 Hi.
Hi.
Who is this?
This is Vinod.
How do you spell your first name?
V-I-N-O-D.
And what's your last name?
Madhavraj.
Oh yeah, Vinod, how you doing? Is that Mr. Hall?
Huh?
Is that Mr. Hall?
Oh, I can't hear you. One second.
Who's your teacher, Mr. Hall?
No, Miss Bradford.
Oh, Miss Bradford.
Yeah.
Oh, well, they said it's from. I thought you guys at SEM sort of don't say you're from Townview. I thought you guys just say, okay, hold on, I gotta find your picture here. Is it in the new pictures or old pictures? Ask.
Old.
Vinod. Oh, there you are. Man. Oh, Madaraij. That's how you're. Okay, I got it. There's Vinod. There he is. Hey, you know what? Let me tell you something. This is a multi-million-dollar operation, and we got good graphics. Let's do that graphics again. Hey! Hey, Vinod.
Yeah?
What type of problem you want?
Easy.
Easy. Okay, you got it. You have to answer this problem within 15 seconds, otherwise you get no bell. Okay?
All right.
I want you to tell me what your instinct is within 15 seconds. Nobody, not one person at SEM could say a word, all right? You ready? Ten seconds left. What's the answer, Vinod?
1/3 e to the 3x plus c.
Excellent. All right, well, that was too easy. You want a harder one now?
A little harder.
A little harder, okay.
Okay.
Little harder here, okay. All right, hold on.
Natural law. The natural laws of
Yep.
natural law.
Hey, tell them.
You see ln of absolute value of 1 over...
No, you don't, wait. But no, you don't have to do this one in your head, like the last one.
Okay, 1 second.
Let me give you a little cheering section. Go, Vinod! Okay.
Okay, it's just the natural log of the absolute value of x.
Well, how do you know that? I don't like that. How do you know that? That's too good. And that's seriously, how do you know that? No. Vinod only. Vinod only.
I just know it.
Well, come on now. You just know it?
Yeah.
Oh, okay. Well, what do you guys set equal to you? So are you just doing derivatives backwards in your head?
Miss Bradford said we don't do it that way.
Okay, get Miss Bradford on the phone.
Okay.
You don't believe it, do you?
What? So he's just doing like derivatives backwards in his head?
Uh-huh.
Okay, well,
Pulling
so
out the 1 over x.
what's that?
Pulling out the 1 over x and putting it with the dx.
So you don't do use substitution. You just sort of teach them like
We just fix it.
really be good at taking derivatives.
That's right.
Okay, thank you.
That's why they're all so smart.
Well, that's wonderful. Put Vinod back on.
Yeah.
Okay. Yeah, but no, that's really good because you recognize that. What you recognize is that if you take the derivative, what you did is really good. The derivative of natural log of x. If you take the derivative of that, then that is equal to 1 over natural log of x times 1 over x, which is that, right?
Mm-hmm.
So if that's the case, then you could, if you did use substitution, you'd realize it's du over u, which is the natural log of u, which is natural log of x plus c. But what you recognize, because you are the great Vinod Maharaja, that you were just superstar. Hey, you know what you get?
What's that? A
You
bell?
get,
Oh.
you get the clap. Hey, ask Miss Bradford if she used to watch Love American Style.
Do you?
Never heard of it.
She never heard of it.
Really? Ask your parents tonight, people. At 7 o'clock was Love American Style. 7:30 was the Brady Bunch. Anyway, never mind. Okay. All right. Well, I got people talking in my ear saying that it was at 9 o'clock. Well, no, you're right. The Partridge Family was on at 7. And that's right. Come on, get happy. Okay. Hey, let's. Okay. You call it again.
Okay, I will.
All right. Thanks.
Bye.
Hey, Erica. How's it going? Erica, happy Valentine's Day.
Say that again?
Who's your Valentine? Erica,
Yes?
who's your Valentine?
I'm not sure yet.
You're not Bendrick? Is that?
Don't you have another picture?
You don't like that picture?
No,
Okay. Well, what's the other picture?
I'm not sure. Oh, I was outside on the desk,
You're outside the desk.
outside the classroom.
Okay. I'm looking for another 15 seconds because we got. Oh, look at that! I tell ya. Oh. Erica, you know what? You know, if you get rid of the L's in your last name and put a T, you know what it means?
Bonita.
C. Okay. Hey, Erica.
Yeah.
How's calculus going? What do you want here? You want a hard max min problem? Okay.
If you
Here you
want.
go. Ooh, he says, bring it on.
Sure.
Bring it on. F of x is equal to natural log of x over x. Find all relative extrema.
Relative extremes?
Yeah.
Okay. Go for it and look for the derivative.
Okay, so what's the derivative? Hey, this is pretty hard. So,
It's going to be Hody High.
Hody High, baby. Hody High. Bring it on.
X times 1 over X
Really?
minus
Oh, great.
natural log of X.
What
are you doing? You're not
My
right.
bosses are watching.
Hey, mister, you made another mistake.
I did?
Yeah.
No way.
You're not writing when I'm talking.
Well, I'm sorry. You're right. Okay. Hey, Eric.
Hey, that's $1. That's $1.
No, I didn't make it. No, I have to make a mistake. I just didn't. Omission is okay. So, Erica.
Yeah.
Okay. So, tell me what to do.
Find the derivative is X
All right.
times 1 over X
All right.
minus natural log of X
All right.
times 1
All right.
all over
Uh huh.
X squared.
Okay. So far, so good. That's excellent. Excellent. Bendrick is very happy. Go ahead.
Cancel the X's.
Okay, so I cancel the x's. I got 1 minus natural log of x over x squared. Now this is where it gets hard.
Okay.
So think about this. If we want to find all relative extrema, what do we have to do?
The critical numbers.
Okay, excellent, excellent. So how do we find critical numbers?
Set it equal to 0.
Set what equals
Top and
0?
bottom.
Top and bottom, excellent. Okay, what's the, well, the bottom is 0 at 0, but what about the top? That's where it gets a little hard.
Hold on. It's going to be E.
It's going to be E. How do you know that?
I have a good teacher.
You have a good teacher.
She's not in here right now, but
But
yeah.
mathematically, how do you know that?
Because the natural log of E is 1.
Excellent, because you want to set this equal to 1, right?
Yep.
So it's like 1 minus natural log of x equals 0. 1 is equal to natural log of x. And the natural log of what is 1? It's E. Or you could E both sides. So we got E. Okay. Well,
Yeah, these are great.
okay, so we got 2 critical numbers, but this really isn't considered a critical number 0. Do you know why?
I don't know why.
Well, because it's not in the domain. It's not really part of the
that's
original
right.
function. So, but that's okay because it's it's like a critical number light or something. I don't know. So we got these 2 things. Now what do we do?
Go plug it in.
Plug it in.
Pick
So
a
what are we
number.
going to plug in?
Pick a number. Pick a negative number.
Okay, if I pick a negative number,
Oh yeah. Okay.
what's the domain for natural log of x?
It's gonna be positive.
God, Erica, that is awesome. That is, man, you're right. It's all
Thank you,
positive.
I know.
So therefore, we don't even have to worry about anything less than 0 because it's not even in the deal.
Oh gosh. Buzz is
You
talking
tell him,
again.
Erica.
I like 6 by 5.
Buzz.
Erica,
Yeah.
so talk to me. So we don't have to worry about negative numbers. So what's a number in between 0 and E?
1. 1.
1, excellent. So therefore, what's natural log of 1 equal to?
It's gonna be 0.
It's going to be 0. Natural log of 1 is 0, so you got 1 over 1, so it's positive.
Yeah.
What about if you plug in E squared? What's 1 minus natural log of E squared?
It's gonna be 1 minus 2.
It's going to be 1 minus 2, which is negative. Wow. You're really smart, aren't you?
Yep, I am.
Okay.
And this is my.
So we got relative max at E, and then if you natural log of E is 1, comma 1 over E, right?
Yeah.
Hey,
All right.
fine
Am I
job.
done?
Make sure you call in again, okay?
All right.
Hey, and you didn't get you that $1 that time.
Yes, I am.
Not next time. I didn't make a mistake.
Next time I'll get it.
Thanks.
Bye.
Hey, Drew.
Fleischer, what's up?
What's going on?
Hey, happy Valentine's Day.
Happy Valentine's Day to you too, Drew.
Hey,
Let's do a quick problem here, okay?
okay.
What's the derivative of e to the x squared divided by x?
Okay. Someone wants to know if we already did this.
No, you did not already do this.
Okay. All right, the derivative of, would it be ln
What?
of e?
ln of e?
The derivative of 1 over x is ln, isn't it?
When you have a quotient, what do you do?
We're deriving e to the x squared.
Right.
Okay. All right, so you derive it's 2e to the x squared.
Okay. When it's Hody High,
Oh,
right?
I forgot. You should have said that.
Okay. Well, I wanted to see.
Okay, Hody High.
Right.
It's x times 2e x squared.
Times what?
E x squared.
What's the derivative of e to the x squared?
Okay. It's
It's 2x,
Oh.
2x e to the x.
hold on, I can't hear. I can't hear you on my phone. I'm trying to listen to this
Okay.
TV. It's x times
I'm being burned alive.
what is it? 2ex squared.
Okay, what's the derivative of e to the x squared? It's e to the x squared times what?
2x.
Times 2x, right? So
Ooh.
that's the ho d
I
high
told you from the beginning.
minus
Okay,
high
minus ex squared
d
times
ho
1.
all over ho squared,
Yes.
right? So we could simplify that. How can we, I'm going to do this.
Okay.
Tell me how we could simplify the numerator now.
Over x squared. Okay.
How can we simplify the
Can
numerator?
you divide 2x squared by x squared?
No, because it has to be in both
Okay.
terms.
The x squared. Get rid of the ex squared.
Okay, excellent. So it's e to the x squared times 2x squared minus 1 all over x squared, right?
Yes.
Hey,
'cause
Drew-
you factor it out. You factor it out.
Excellent. Hey, Drew?
Yes.
You got to make sure you give your picture, Miss Arthur.
Oh, I keep forgetting. No, I'll be sure to have it for next week.
All right.
Oh, and there's a
He's got some
there's
pictures,
a
you just can't show them on TV.
Are you going to go be at the prep session week from Saturday?
oh yeah definitely.
Oh, yeah.
Hey, and there's a guy here who's interested in a girl who plays soccer at BA, and he wants Miss Arthur to give a response.
Okay, we'll work on that.
All right,
okay?
thanks. It was a pleasure. Take care.
You too, Drew.
All right,
Thanks.
bye.
Skyline. Hello,
Hello?
Raiders.
Hello?
Hello.
Hello?
Hi.
Hi.
How you?
Fine.
What's your name?
Shayla.
Shayla what?
Arellano.
Oh, are you with Mr. Morrow or? Woo. Are you with Mr. Morrow or Miss Johnson?
Mr. Morrow.
Mr. Morrow. There you are. I think look at that there. It's Hey! That's a fine picture. Hey, you got a test tomorrow?
Yeah.
Are you nervous about it?
Yes.
Why?
Because I wasn't here one day and I kind of missed a lot of things.
Oh, man. Well, that's why you're here after school working with this and then working with Mr. Morrow after this, right?
Yeah.
Okay, try this problem.
One here.
Okay, when another word for area, what are you thinking about? What's the first thing through your mind?
The integral.
The integral, excellent. Area, definite integral, area, definite integral, area, right, excellent.
So you find the integral.
When in doubt, you're right. That's excellent, Shayla. What you're saying is it's integral. If you really don't even have a real idea, taking back a look at this problem, what are you going to integrate it from what to what? Well, if you just had to take a wild guess, what would it be?
From 0 to ln of 3.
Right, from 0 to the natural log of 3, right?
Uh-huh.
I mean, if you really did it, I mean, you could sort of, fall into the answer here, right?
Uh-huh.
So what's the integral of e to the x?
EX.
Okay, and when we plug in, what's e to the natural log of 3 minus e to the 0? Take your time.
3 minus 1.
What's 3 minus 1?
2.
Ding, 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 ding. Fine job, Shayla. Hey, Shayla, make sure Mr. Morrow gives you plenty of snacks so you could stay tonight to study
Oh,
for
he
your test.
gave us a Coke, Doritos, and candy.
Hey, I know he takes care of you. Hey, make sure you call in again, okay?
Happy Valentine's Day.
You too. Hey, great job, Shayla. Bill Massey.
Hello?
I got a picture here that
Yeah, I finally sent that picture in there.
this is a PG show here. I don't know about this. This is
What do you mean?
I mean, it's a little. Is there a chaperone there? Hey, Bill.
Yeah?
Was there a chaperone at that dance?
Yes, there was. That was homecoming.
All right, just want to make sure. Hey, what type of problem do you want? Do you want something for your test tomorrow?
Sure.
I'm running out
I
of.
could use as much practice as I can get.
Hey, okay. Well, let's try this one then. Let's do this one. Find all relative extrema if fx is equal x e to 2x.
Okay, now first we want to take the first derivative.
Uh-huh.
And so we do that with the product rule.
Okay.
And so that would be 2e to the 2x times 1 plus x times e to the 2x.
Okay. Wait. Say that first times the second plus the. What's the plus thing?
I beg your pardon?
Again. Say that. What goes after the plus sign again?
Plus sign is x. I'm sorry, 1
Okay, 1
times e to the 2x.
Okay, so it's just e to 2x times 1, right?
Yes.
So that's the derivative. What do we do now?
You find where that would equal 0.
Okay. Ooh, that looks pretty menacing.
So you can chain out the e to the 2x times 2x plus 1.
Hey, what does Miss Harmon say when you say chain out? Doesn't she sing? Does she?
She always sings that Aretha Franklin song.
That's right. Chain. Okay, no, I won't sing. So it looks like that, right?
Yes.
Okay, now when does this equal 0? You're doing great, Bill. That's awesome.
And so we know that x must equal a negative 1/2.
So x. So what does this equal? What about that?
E to any power is always positive.
Very good. So it only equals 0 at negative 1/2, right?
Yeah.
So therefore, so we got one critical point now. Is it min, max, or neither?
Not quite sure yet. Let's see.
Okay.
We could plug in a number lower than negative 1/2, maybe negative 1.
Okay. Plug in negative 1. What do you get? What is this always going to be?
It's always going to be positive.
And so if you plug in negative 1 into here, what do you get?
And so you have you end up with a negative number.
Right. Okay. So if you plug in a positive number, or
when you plug in anything higher than negative 1/2, you're going to get a positive number.
So what do we know about?
And
then the
so
function?
this would be a relative min.
Relative min at what point?
At negative 1/2. I can't see the original function.
Okay.
1/2, comma, let's see.
Oops.
And then so you have negative 1/2, and see that's negative 1/2 e to the negative 1.
Right. So negative 1/2 e to negative 1. Excellent. So or just negative 1 over 2e, right?
Yes.
Hey, Bill.
Yes.
Fine job. That was a pretty hard problem.
Thank you.
You're gonna be better tomorrow. And make sure you call in again, all right?
I'm sorry, I can't hear you.
Make sure you call in again.
Thank you, I will.
All right.
Bye.
Cynthia. Did y'all wish Miss Arthur a happy Valentine's Day?
You mean Brzezinski?
What?
You mean Brzezinski?
For what?
Miss Brzezinski.
They told me it was Bride Adams. I'm sorry. It's all Michael's fault.
You made a mistake. Give me a dollar.
No, it has to be a math mistake. Math mistake.
I can't even.
Erica.
What? You're feisty.
That's right, Erica. Erica Bonilla. Hey, who am I talking to?
Cynthia.
Cynthia. Hi, Cynthia.
Hi.
You're not quite as loquacious as loquacious. What does loquacious mean?
Energetic.
That's a good guess.
Beautiful. See your glamour shot.
My glamour shot.
Oh, look at that! Now, where'd you get this here? You got this at Logan. Is this
Yeah.
Cynthia Benavides?
Yeah.
Look at that! I tell you.
Available.
No.
Hey, Cynthia. Cynthia.
Yeah.
What type of problem do you want? Are you nervous?
Yeah.
Yeah, I am too. So that's okay. Hey, let's try something. Let's try something not too imposing. How about f of x is equal natural log of x? This is on your test. Did you already take your test, or you take it tomorrow?
Yeah, I already took it.
Okay. All right. Well, then you could do this problem then, right?
Find the derivative.
Okay. So what is the derivative?
It's 1.
What's that?
Hody high.
Hody high, baby. Hody high.
So it's x times It's 1 over x.
Okay.
Minus the natural log of x.
Hey, I'm writing, hey, Erica, I'm writing down what she tells me.
All over x squared.
Over x squared. That's excellent, and it's, man, I tell you.
You can cancel the x's.
Right, so it comes out to be this, right? So what's f prime of e squared going to be? Hey, try to do it. Yeah, try to do it in your. See if you can do it in your head.
-1.
Excellent, right? Because natural log of e squared is equal to what?
2.
Excellent, great job. So it's 1 minus 2, which is -1 over what?
E to the 4.
Hey, that is a fine job, Cynthia. That's really good. Tell Miss Brzezinski you did great, all right? Is she back yet?
Yeah.
Okay, hi, Miss Brzezinski. Did you, how was the appraisal in the library?
How was what?
How was the appraisal in the library? I heard on the announcements.
It was awesome.
Okay. I don't know what you're just talking about, but hey, make sure you call in again, okay?
Okay.
Fine job, Cynthia.
Bye.
Hey,
Veronica,
Yes.
are these the Patriots?
Yes.
Who won the Super Bowl? Who won the Super Bowl?
I don't know. Oh, the Patriots.
I don't know.
I didn't see it.
Who were the original people in the United States?
The Patriots?
Yeah! Something like that. Okay, here's a tough question. What were the New England Patriots? Never mind. First name. They used to be called the Boston Patriots. Hey, what are you doing in class right now?
We're watching you.
No, I mean, what topic are you covering with Mr. Wynn? Are you doing the natural log and E stuff? Are you doing this
The natural logs.
and this E stuff also?
Yeah.
Okay, I'm gonna give you a good problem then.
I don't understand those stuff.
Oh, you don't?
No.
Okay, I'm gonna give you 2 problems here. Okay.
Okay.
I want to show you a little trick. Okay, when you have to integrate this, Mr. Wynn, have you gone over this yet?
Yes.
Okay. All right. So, Veronica,
Yes.
tell me what do you have to do when you integrate?
You need to, find what u is.
Excellent. Great job. Awesome. So, what are the possibilities for you?
X squared?
Right. And you know what the little key is? The little key is that whenever you have one e in the integral,
Uh-huh.
you always set u equal to its exponent. It works out like 98% of the time. So it'll give you a shortcut on what to set equal to u.
Okay.
So u is the x squared, and now it's going to be pretty easy. So keep going.
du equals 2x dx.
du is equal to 2x dx, right?
Okay.
Okay, so now what do we got? How can we transfer that?
You add a 2 in front of the x.
Okay, add a 2 in front of the x. Okay,
Okay.
so keep going. I'm not going to write it down like that, though, but I know what you're talking
And
about.
then you, outside of the integral, you put 1/2.
Excellent. So it's just 1/2 times the integral of what? Great job.
Okay. And then it equals EU du.
E to the u du.
Yes.
Okay. And the integral of e to the u is?
Let me see. Oh, EU?
It's excellent. E to the u. You're doing great. Veronica, you're doing great. Go Patriots. So the answer is 1/2 e to the u, which is just 1/2 e to the x squared plus c, right?
Yes.
Okay, that's one problem, right? So whenever you have like one e, that's what you know what to do. That's what you know what to do. Okay, now I'm going to give you another problem, okay? I'm going to give you one that looks really, really hard, all right?
Okay.
And it is really, really hard. This is like,
That was hard.
well, this one's even harder, okay? Okay. When you integrate this, now this looks like a really hard problem, right?
Yeah, a lot
Okay.
of sines.
What's that?
Cosine. Sine and cosine.
Yeah,
Those
those
are-
I hate those things, right?
Me too.
Yeah, I know, me too. Hey, so talking about that little trick that, well, I'm trying to, what do you think you're going to set equal to u?
Sine x,
Because why?
because it's over the e.
Yeah, there's only one e in the problem. Like, real quickly, if you had something like this, you wouldn't set e to 2x cosine e to 2x. You would not set u equal to 2x here because you got two e's. But when you only have one e, that's what you do. Okay?
Okay.
So only when you have one e. That's awesome. So u is equal to sine of x. So
Yeah.
what's du equal to?
Cosine x dx.
Cosine x dx. Awesome, awesome. So then how do you rewrite that thing?
It's integral e u du.
And that's pretty easy. What's the integral of e to the u?
It's eu plus c.
Excellent. So the answer is just e to the sine of x plus c, which makes sense because when you take the derivative of that, that's what you get. But this thing that looks really hard, you did it really easily, right?
Yes.
Hey, are you coming a week from Saturday?
My time is up.
Your time is up.
No,
that's just like
he wants you to show my picture. My teacher.
I don't think I have your picture. When
we
did
emailed it to you
when did he email it to me?
about 2 hours ago.
Well, I wasn't able to get it, but I'll get it next week. Okay.
Okay.
Make sure you
Maybe
call
I'll
in next
call.
week. Yeah, give me a call. We'll talk. All right.
Okay.
Hey, you gonna be there a week from Saturday?
Yes.
Okay. And I'll make sure I get those pictures next week. Okay, Veronica?
Okay.
Call in again. Great job.
Okay. Bye.
Marlon Hodge?
Hey, how you doing?
Pretty good. How are you doing?
I'm doing fine. I told you I'll call you back next week.
You what?
I told you I was gonna call you back next week.
That's right. You said you're going to get
Yeah.
me. That's right. How's things going over there?
It's going pretty good.
Remember, and you, if I remember, you're majoring in like some math science thing, right?
Yeah.
And where you want to go to school again?
Ronnie said give me a great one.
Where do you want?
Where I want to go to school? I'm undecided right now.
Undecided?
Yeah.
That's it's most people are undecided in their majors for a long time. Hey, Marlon,
Yes, sir.
you're in BC, aren't you?
Yes, sir.
Okay, I'm going to give you a Miss Bradford. What section are you on in BC?
Polar.
You're on Polar. Okay, this is just going to be a BC problem here.
Yes, sir.
All right. I don't mean to scare this. So this is something that the AB people do not have to know.
Okay, it would be a parts problem, wouldn't it? So,
Yeah, you're right. It'd be a parts problem.
So u would equal the natural log of x, right?
Okay, so u is equal natural log of x.
Okay.
Once again, this is not an AB problem. I know we have a bunch of BC people.
And d
so-
of u would equal d of x.
What's that?
Wouldn't d of u equal d of
DV,
x?
DV, right?
Oh yeah, dv. Okay.
Yeah, okay, that's good. That's good. Excellent.
dv would equal d of x, and u would equal natural log x. So dv would. Where do I start? After that, I do du, right?
Yeah, you got to find DU. So
It would
what's
be
the-
1 over x.
Excellent. And then what is, if dV is 1 dx, what's V equal to?
Okay, dv 1 dx.
What's
just
the integral of
it'll
1?
Be 1 over dx, right?
Well, what's the integral of 1?
X.
Yeah, just x. Okay.
Oh,
Now, do you
okay.
remember the formula?
No.
Okay.
Honestly, not.
It's the integral. Oh, that's all right. You just got to memorize the formula. It's the integral of udv is
Ms.
equal to
Bradford told me-
uv. What? Ms. Bradford told
She
you.
told me to tell you we do the table.
Oh, you do the. But
Yeah,
you,
but I want to learn a different way to
but can
challenge
you,
my mind.
can you do the table on? I don't think you. Hey, Miss Bradford, can you do the table on this one?
Yes, I probably could.
Nah, I think
I ain't been practicing that kind of life, so.
Hey, hey, Marlon.
Yes, sir.
You can't do. You can only do the tables when you set your u when you take the derivatives down to 0.
Okay. She says she's not talking about tabular.
Oh, not talking about. I know what you're talking about. You're doing the crisscross thing.
Yeah, she say right.
Okay. Well then, what if you do the crisscross thing? Then you got. I don't want to mess you up. You got uv
Yes,
x
sir.
natural log of x minus the integral of v du, which is just x times 1 over x, which is the integral of 1 dx.
Yes, sir.
So the answer. What's the integral of 1?
Integral of x.
Right. And you could check your answer by taking the derivative of this, and you get that, right? Hey, Marlon.
Yeah, can I give a shout out to my homeboy Jerome?
Jerome who?
Jerome Moore.
Jerome Moore?
Yes, sir.
Do I shout out or you shout out?
You shout out.
How do you shout out? I'm Anglo with a capital A.
Just like.
Jerome!
Hey, what's up?
Hey, what's up, Jerome?
Yeah, it didn't do the clappy thing.
Oh, the clappy thing?
The clappy thing. Yeah.
Hey, Jerome. Where's Jerome go to school?
They have the picture.
He got an SM.
Okay. Well, is he watching?
Yeah, he's watching right now.
Well, tell him to call in next time, all right?
Call in next time.
All right, thanks a lot.
Bye-bye.
Bye. Who is it?
Help.
Hep,
Yes.
what's going on?
Pretty good, thank you.
No, thank you. Thank you. You ready for your test tomorrow?
Yes,
You are?
I
Hey,
guess.
You guess? What's the hardest stuff that, on your test tomorrow? What's the thing that you are the most worried about? Like, what's the type of problems that you're most worried about?
I guess everything.
You guess everything. Okay.
Yeah.
Well, that leaves me open here. So how about this? Hey, you tell me which of these is equal to natural log of 4, okay? I'm just going to write a bunch of these, okay? This is A. Can you see all these? Hello?
Hello?
Can you see all these?
Yes.
Okay, I'm thinking here. Hold on. Okay, I'm going to give you one more. You're going to have to tell me which of these is equal natural log of 4.
I believe it could B and C.
B and C. Hold on, I'm not done yet. Okay, here you go. B and C?
Yes.
Well, what about A? What does A equal?
Wait, A? That's going to be natural log of 6 because natural log of 8 minus natural log of 2.
Oh, now is that okay? Now here's a good question: is natural log of what is natural log of 8 minus natural log of 2 equal to?
Natural.
Does this equal natural log of 8 minus natural log of 2 equal natural log of 8 over natural log of 2?
It's natural log of 4.
This is natural log of 4 because the rule is natural log of A minus natural log of B is natural log of A over B, right?
Yes.
So that equals natural log of 4, but that's not what this rule says. Matter of fact, what does this simplify to? What does the A simplify to?
Natural log of 6.
What's that? No. Hey, how can you simplify natural log of 8, Hap? What does that equal to?
Natural log of 6.
Okay, natural log of 8, let's rewrite it as natural log of 2 cubed.
Yeah.
Okay, and how can you simplify natural log of 2 cubed?
Move 3 to the front.
Excellent, excellent. Move 3 to the front. 3 natural log of 2 over natural log of 2, so that's just equal to 3. That is equal to 3.
Yes.
Right?
Yes.
That's great. Okay, so, but you said B and C. Why is B equal to natural log of 4?
It's going to be natural log 4 over 1.
It's going to be natural log of 4 over 1, which is natural log of 4. Or what's another way to look at it? What do we know natural log of 1 is equal to?
It's equal to 0.
Excellent. It's equal to 0. So natural log of 4 minus 0 is natural log of 4. And now why is C equal to natural log of 4?
Because power of 2 to the natural log of 2.
Excellent. Natural log of 2 squared is natural log of 4. What about D? Why isn't, what's wrong with D?
Oh. That's undefined because natural log of 1 is equal to 0.
Excellent. Excellent. Okay, what about E? Why isn't E equal to it? Or here's another one. Here's F. Running out of room here. Okay, E or F, is one of those equal natural log of 4?
It's F.
F is Y.
Oh, I get it. If you take integral of 1 over t is equal to natural log of
Right.
t.
It's equal to natural log of t. So
That
it's
natural log of 4.
Right. It's equal to that natural log of 4 minus. And actually, this is the definition of natural log of x. The integral from 1 to a number of 1 over t dt is equal to natural log of whatever this is up there.
Yeah.
And this one, we don't even know how to integrate it. That the BC people know how to do that, but we don't know how to integrate natural log of t. So that's not going to be equal to natural log of 4, right?
Yes.
Hey, Hat.
Yes.
Fine job, Hep.
Thank you.
All right, will you call it again? All right.
Erica.
Bendrick Humphrey.
Hey, how's it going, brother?
Hey, happy Valentine's
Happy
Day.
Valentine's Day, brother.
What's going on, man?
Nothing. Ernest said that Shayla,
Yeah.
that why she didn't say hi to him.
Ernest says Shayla. Hold on for a second. Let me work this out here.
So Ernest,
I
hi Shayla from
All right, let me
Bendrick
get you
and
up here
Ernest.
first. There's Bendrick Humphrey. Don't mess with Bendrick, kid. Bendrick, I think I got you with
You don't have no more. Man, I look too dark. That ain't my
Okay,
color.
hold on. I know. Hold on.
A lot lighter.
Yeah, I got you. I think I got you with a couple women, don't I? Hold on for a second. Man. I know. I'm working. I'm working. As Eric will say, that's $1.
Yeah.
Hurry up, Mrs. Sullivan.
She already said you owe her 4.
I owe her 4.
5, actually.
Well, here you go. How's this one?
Hey now.
Hey now. Okay. So we got to hook up Ernest and Shayla.
Yeah.
Oh, you mean Shayla from Skyline?
Yeah.
Oh.
Ernest can take it, so I can talk to her.
Okay, so I got you. So I said, well, I'll think about that.
Don't show the picture.
What's that?
He said show his picture.
Ernest Esparza, you mean?
Yeah.
Hey, well, let's show. Hold on for a second here.
The wonderful Ernest. Oh, hold on, man.
What do you think?
I think I see a love match.
All right, it's Valentine's Day. Hey, okay, Bendrick. Can we do a little math here? You know, what is this here?
Let's do some easy math.
Some easy math? Well,
Yeah.
I remember you're really smart. Where are you going to school next year?
University of Houston.
What are you going to major in?
Oh no.
Are you going to major in math?
Basketball.
No, what are you going to major in? Hey, you guys are 18 and 11 this year, something like that, right?
Yep.
Okay. Do you start?
Nope.
Okay. Hey, you guys lost a couple great seniors from last year, didn't you?
Yeah, Isaac Hines.
Yeah, they're. Okay, here you go, Bendrick. If the graph shown above is y equals f double prime of x on one end rolls as f concave up.
The function is concave up when the second derivative is positive, and the first derivative is increasing.
Well, it's really good. All you had to do was say it was the first one, but right, it's when the second derivative is positive. But that's good because, well, okay, well, go answer this question first, and then I'm going to change it a little bit on you. So that's great. That's awesome.
Okay. Well, it's concave up from, what is that, a -3 to -1, and from 2 to infinity.
Hey, that's
infinity.
great. It's concave up from -3 to -1, and from 2 to
Positive infinity.
Okay, now, and we always use what? Parentheses or brackets?
Parentheses.
That's right, always. Hey, if this said, okay, how about if it said this? What if it said, if the graph shown above is y is equal f prime of x, then on what intervals is f concave up?
From negative infinity to -2,
All right,
And-
negative infinity, -2. You're quicker than I am, so.
and from 0 to positive infinity.
Hey, that is great. Okay, what about if it says this is f, just f of x? When is f concave up?
From -1
Yeah.
to positive infinity.
Excellent. Yeah, it's so hard. It's like somewhere around -1. It's hard to see. Hey, Bendrick.
Yes.
Hey, that is really, really good.
Thanks.
I mean, that is like, man, if they ask one of those type of problems on the exam nationally, a lot of people miss those because they don't get it like you get it. And it's really, it's really,
It's the teacher.
yeah, it would be really good because since you know it a lot more than the national average, if you do well on that question, it's going to be great. Hey, put Ernest on. I want to ask Ernest a question. Hello?
Ernest.
Or
Hello.
get Ernest on the line.
Here comes Ernest. Here comes Ernest.
Hello?
Hey, Ernest?
Yeah.
Now, do you know Shayla?
Yeah.
You do?
Yeah.
How do you know her?
I went to middle school with her.
Where'd you go to middle school?
Benjamin Franklin.
You went to school at Benjamin Franklin?
Yeah.
Well, how come you didn't go to Hillcrest?
I don't know, 'cause I live over here.
So why'd you go to middle school at Franklin?
Huh?
Why'd you go to middle school at Franklin?
'Cause my mom didn't want me over here.
Okay, well, hey, you're really you got a great calculus teacher now, right?
Yeah.
You know, like because Because when you were at when you were at Franklin, you know, who was the calculus teacher at Hillcrest. You didn't want that person.
Yeah, I know who she was.
It was me.
Oh, I thought it was that lady. Oh, I thought it was a lady.
Hey, hey, Ernest.
Yeah.
I'm just teasing you. No, yeah, because 4 years ago I was teaching there. But so and Shayla went to. So did you have Miss Scott?
Yeah.
Yeah. Wow, you had a great algebra teacher, didn't you?
Mm-hmm.
Okay. I'm going to ask you a problem.
Oh,
Oh man, I hate when that happens.
well, I don't got. Hold on. I need to get a paper.
Okay. What,
All right.
did you think do you think I just wanted to chat?
Yeah.
Okay. Hey, okay, here you go. You ready?
Yeah.
Okay, the integral of, how about e to the natural log of x all over x squared.
Oh.
Wait, hold on. From 1 to e.
Oh. Wait. Hold on.
That's a
Okay,
pretty
I
good
already
problem.
wrote it down. E to the natural log of x equals x.
Okay, so excellent, Ernest. E to the natural log of x is equal to x over x squared.
So it's integrating from x. Integrate from 1 to e, x over x squared dx.
Can we simplify anything?
Oh, 1 over x.
Yeah, that's good, Ernest, man. That's good. Okay, so now where do we go from here?
You rewrite it. No. You would natural log integrating from no. Natural log of absolute value of x,
Okay, excellent. So it's
and then run it from 1 to e.
natural log of x. Natural log of x from 1 to e. So it's natural log of e minus natural log of 1.
Yeah.
Okay?
And then it's just natural log of e.
So it's natural log of e, which is 1 minus 0, which is equal to 1, right?
Yeah.
Okay, hey, let's do another problem.
Okay.
Oh, man.
Yeah.
Or do you want, give the phone to someone else.
John!
Anybody you want.
Hello,
Who's this?
Emily.
Okay, as long as it wasn't Erica, because I can't afford to talk to Erica.
You and me both.
Hey, Emily, I got your picture. Emily Rojas.
Yeah,
Do you know what the previous superintendent in Dallas Public Schools' last name was?
Waldemar something Rojas. Mr. Rojas.
Yeah, I think it was Dr. Rojas. Hey, that's a fine picture here.
Thank you.
Thank you. Hey, let's see. What type of problem here? How about if f of x is equal to? Well, let's try something a little bit. Nah, we won't be. We'll be sort of nice. How about sine of x all over x? Let's find f. Hello?
Hello.
I'm sorry. Let's find f prime of x, and then f prime of. No. That was Michael. Go ahead and try to do those.
F prime of what?
F prime pi over 2.
Okay. You have to do Hody High.
Hody hi, baby, bring it on.
X times cosine x minus sine x over x squared.
All right, that's good. So then for what's f prime of pi over 2 equal to?
Excuse me?
Then what's f prime of pi over 2 equal to?
Oh, pi over 2 times cosine pi over 2.
What's cosine of pi over 2?
0?
0, excellent. So it's 0 minus,
Sine pi over 2.
which
It's
is what?
1.
What's sine of pi over 2 equal to?
1.
Yeah, so it's negative 1 all over pi over 2 quantity squared. Hey, if we wanted to simplify this into one fraction, what would it be?
To simplify it, you have to,
What's happening now?
negative 4
Uh-huh.
over pi squared.
Excellent. Man, Emily,
Huh.
where'd you go middle school?
I went to St. Clair of Assisi Catholic School.
Where's that? That's not in Dallas Public Schools.
No, it's a private school.
In Dallas?
Yeah.
Wow. What middle school would you have gone to?
Probably Quintanilla.
All right. Hey, Emily, make sure you come a week from Saturday to that prep session, all right?
If it's 5 o'clock and they're still talking, they just move.
What?
Exactly, just go right in.
Hey, Emily, have a real good weekend. Happy Valentine's Day, everybody. Hello? They hung up. Y'all, see ya.